Section 9.4, solving quadratic equations by completing the square. So completing the square is another method for solving a quadratic equation. So far we've looked at solving quadratic equations by graphing parabolas and looking for x-intercept. And also if we have either an x squared or some expression with x squared in an equation, then we've sometimes been able to solve with square roots. Sometimes, however, we have an x squared and a bx in our equation, and we can't just solve using the square roots. So this is going to be another method that we can use. Now the diagram that you see there will show you what completing the square looks like kind of geometrically. So we're going to go over that in class, but do draw that diagram, or both diagrams, and we'll cover it in class when we're together. Alright, let's see what we're going to do here. So what we're going to do is we're going to start with an expression, x squared plus 4x, and we're going to try to complete the square. In order to do this, we're going to follow these three steps. Step 1 is to find 1/2 of b, the coefficient of x. So I can see here that my b equals 4. That's my coefficient of x. So I need to find half of that. So I do 4 divided by 2, which is 2. And then step 2 says to square the result from step 1. So I'm going to take that 2 and square it, and that's going to equal 4. It won't always come back to the value that b was originally. This is just one particular example where it does. And I'm going to add that to this answer of 4 to my expression. So I'm going to add 4 here. So I'm looking at x squared plus 4x plus 4. And when I do that, I'm able to actually factor the resulting expression. Now, I could think of this kind of the old-fashioned way and say what two numbers multiply to 4 and add up to 4 and get 2 and 2, which would be x plus 2 times x plus 2. But I could also realize that I've chosen this number so that it works out perfectly to make a perfect square. It's going to be x plus 2 squared, and this plus 2 will actually always come from my result after I divide my b by 2. And so what this has done is by adding 4, I've been able to take x plus 2 squared, which is a perfect square, and that's a completed version of x squared plus 4x. I started with some start of an expression, and now I've made it into a perfect square, which is going to be useful going forward. Alright, so here are 3 examples to look at. We're starting with expressions that just have an x squared plus bx. We want to add a c on to make them perfect squares. So for this first example, x squared plus 7x, I'm going to take my 7, divide it by 2. Now I don't want to make it 3.5. I'm going to keep it as a fraction 7/2. Then I take 7/2. And I square that. Now when I square that fraction, that means squaring the numerator and the denominator, so I'm going to get 49/4. That means what I want to add to this expression is 49/4, and now it factors nicely. I'm always going to be starting with my x, and then I look to what happens after I divide it by 2, and that's what's going to go with it. It's a positive 7/2, so I'm going to have plus 7/2, and that's squared. That's my first answer there. Second one up top is negative 12 is the coefficient of b. So I'm going to do negative 12 divided by 2 is negative 6. And then negative 6 squared, remember negative times a negative is a positive, so that's 36. So I'll add 36 to each side. I'll bring this down to factor here. Now when I go to factor this, I'm going to start again with my x, and I have to make sure now that I use the right sign. The negative 12 divided by 2 is a negative 6, and so I have to put a minus 6 on the inside of my binomial before I square it. I'm always going to be adding a positive here because I'm going to be squaring something to get that, but it's what we have. We have to make sure that we have the correct sign on the inside based on what we had there. The sign on the inside should match the sign in front of the b. Something to keep in mind. Alright, and then the last case, I have 1/2 is my coefficient. It's tough to do 1/2 divided by 2, probably an easier way to think about that is 1/2 times 1/2. That's actually going to be 1/4. Instead of dividing by 2, you can multiply by 1/2. And so after you get 1/4, I then square that, and that's just like what I had before. With the 7/2, I square the numerator and the denominator. 1 squared is 1, 4 squared is 16. So I'm going to add 1/16 to each side, or to the expression. And now that factors, and I know it's going to be x. I look into this right here, and I got 1/4. So it's x plus 1/4 squared. And those are my final answers here. At this point, it may seem kind of strange that we're doing this. This is just setting us up to be able to use this in the future. So now let's put completing the square to use. We can solve a quadratic equation by completing the square. And what's convenient is if we actually have it set up as x squared plus 8x equals 9. We have that x squared plus bx on one side of the equation and the 9 on the other. And so what I'm going to do is I'm going to complete the square on the left side of the equation. So I ignore the 9 for a second. I look at x squared plus 8x. So I'm going to take the 8, which is my coefficient of the x, divide by 2. That gives me 4. Then I take that 4, square it, and I get 16. So what I'm going to do is I'm going to take my original equation, x squared plus 8x equals 9, and I'm going to add the 16 to the left side of the equation, because that's how I complete the square. But if I do something to the left side, I also have to do it to the right side. In this case, I also have to add a 16 to the right side. This makes my equation x squared plus 8x plus 16 equals 25. And now, because I've completed a square on the left side of the equation, I can factor that pretty quickly into x plus 4 squared equals 25. And now this looks like exactly the same type of problem I had in section 9.3. I can solve this by using the square root property of both sides. Take the square root here and the square root here, and I'm left with x plus 4 equals, now I have to remember my plus or minus, 5. Subtracting 4 from each side of the equation and putting that in front of the plus or minus gives me negative 4 plus or minus 5. Those are my two solutions. Now, because those are numbers that I can easily combine, I want to express them as two different answers that are specific. My first answer would come from negative 4 plus 5, which would give me x equals 1. My second answer would come from negative 4 minus 5, which would be x equals negative 9. And those are my two solutions. So by having it set up in a nice convenient manner, we were able to complete the square and then solve based on the square root property we learned in the last section. All right, let's try this again. All right, so let's give it a go on these two problems here. They're both set up in a nice format. X squared plus bx equals a c. And so start by trying to complete the square on the left. I've got negative 5. I'm going to divide that by 2. It doesn't work out evenly, so I keep it as a fraction. Negative 5 over 2. Negative 5 over 2. Now I get squared, so it's negative squared becomes a positive. Square the numerator is 25. Square the denominator is 4. And I'm going to rewrite my original equation, adding that value to each side. So x squared minus 5x plus 25 over 4 equals negative 6 plus 25 over 4. Now, the left side I know is going to factor really easily. It's going to be x and then negative 5 halves, or minus 5 halves, squared, equals. Now, the thing to keep in mind here is that I have to combine negative 6 and 25 fourths. I want to probably use a common denominator, and negative 6 could be written as negative 24 fourths, so that's just going to equal 1/4. Now I will take the square root of each side, which leaves me with x minus 5 halves equals, I have plus or minus here, because it's 1/4 is positive, and I take the square root of 1, which is 1, and the square root of 4, which is 2. So now I'm going to split this up into two different equations. I'm going to start with x minus 5/2 equals 1/2, and my other equation will be x minus 5/2. That's a little messy there. Try to clean that up. There we go. Equals negative 1/2. And when I add 5/2 in each case, I'm going to get, this is going to be 6/2, which means x equals 3. And the other one, I'm going to get x equals 4/2. So my other answer is x equals 2. Those are my two answers for that right there. Alright, so now I'm going to try to do this again, just with the second example. X squared plus 12x equals negative 16. So start by taking my coefficient of x, which is my b. 12 divided by 2 is 6. And 6 squared is 36. So I'm going to add 36 to each side here. X squared plus 12x plus 36 equals negative 16 plus 36. And left side is going to factor into the x plus 6 squared. And the right side becomes 20. So now when I go to take the square root, 20 is positive, but it's not a perfect square. So I can't get a nice number for it. I will have to include plus or minus, but I can't get it exact. So what I'd have to do is I'd have to simplify that. And the square root of 20 just actually simplifies to 2 square root of 5. So then I subtract 6 from each side, and I'm going to put that negative 6 in front of the plus or minus, and I'm going to get my final answer there. So if you don't have it working out perfectly, leave it in that notation so you have your two answers covered that way. Alright, let's try a couple more. So if your equation's not set up as conveniently, you can get that way by moving some things around with some algebra. We have to move the constant to the other side and divide everything by a so that we have just x squared plus bx equals a number. So in this case, I'm going to start by adding 15 to each side. And then I'm going to divide everything by 4. So it works out nicely on the left. X squared plus 2x equals, it doesn't work out nicely on the right, but that's okay. I just leave it as 15/4. Now I go and complete the square. Take my coefficient of b, or coefficient of x, which is b. 2 divided by 2 is 1. 1 squared is 1, so I'm going to add 1 to each side. X squared plus 2x plus 1 equals 15/4 plus 1. Now the left side factors x plus 1 squared, and the 1 I probably want to treat as 4/4 in order to add it to 15/4, and I get 19/4. So now I can take the square root, and I'm just going to bring my answer over to the right here. That's going to be x plus 1 equals, 19/4 is positive, so I have to include plus or minus. But the 19 is not a perfect square, so I'm going to have a square root of 19 up top. Fortunately, my denominator is a perfect square. The square root of 4 is 2. So now when I rewrite it, just subtract 1 from each side, put that negative 1 in front of the plus or minus, and I get the square root of 19 over 2. It's weird that that's our final answer, right? I mean, we'd like to have a solid number, but that's not the case here. We have irrational numbers, numbers that involve radicals, and that's it. That's all you have to do. So any quadratic equation can be set up so you can use completing the square. All right, one last problem for you to try yourself. Use the last example as a basis for this, and pause the video, try to work it out, and then come back to check your work. Okay, let's see how you did. All right, so there you go. You can check your work. Your two solutions should end up being 1 and -3. You could plug those back into the original equation. It would make it true. But if you want to pause the video to check your work, you can do that at this time. Otherwise, hope this has made a lot of sense.